Have you ever wondered how the tiniest particles in our universe behave? Well, that's where the fascinating field of quantum mechanics comes into play. It's a branch of physics that delves into the mysterious world of particles at the quantum level, a realm where everyday rules of physics take a back seat. Quantum mechanics was born in the early 20th century, a time of great scientific upheaval. Scientists like Max Planck and Albert Einstein were pushing the boundaries of what we knew about the universe. This radical shift in understanding led to a revolution in our perception of nature. In the quantum realm, particles can exist in multiple places at once, teleport, and even affect each other from light years away. It might sound like something out of a sci-fi novel, but it's all part of the strange and beautiful reality of quantum mechanics. So, buckle up as we dive into the captivating world of quantum mechanics. Imagine trying to watch a tiny hummingbird with a pair of binoculars, but the moment you try to focus, it's already flown to a new spot. Frustrating, isn't it? Welcome to the uncertainty principle. This principle, first proposed by Werner Heisenberg, is a fundamental concept in quantum mechanics. It states that we cannot precisely measure both the position and momentum of a particle at the same time. You might ask, why is that? Well, let's go back to our hummingbird. Imagine the hummingbird is a particle. You're trying to pinpoint its location with your binoculars. That's like trying to measure its position. But while you're doing this, the hummingbird is also buzzing around, flapping its wings, changing its direction. In other words, it's got momentum. Just as you focus on where it is, it zips away. That's the uncertainty principle in action. In the quantum world, the more precisely you try to measure a particle's position, the less accurately you can know its momentum, and vice versa. It's not because our tools aren't sharp enough, it's a fundamental aspect of nature itself. This might sound strange because we're used to a world where we can measure things like speed and location with precision. But in the quantum realm, things don't behave like we expect them to. Just as you can't pin down the hummingbird, you can't pin down a quantum particle. Intriguing, isn't it? Ever wished you could be in two places at once? In the quantum world, that's not just wishful thinking. Welcome to the curious concept of superposition, a fundamental principle of quantum mechanics. This mind-boggling idea suggests that a quantum particle, like an electron, doesn't exist in one state or another, but in all of its possible states at once. It's as if you were simultaneously sitting, standing, dancing, and running, all until someone checks to see what you're doing. The moment you are observed, you collapse into one state. Now, I know what you're thinking. This sounds more like a magic trick than serious science. But hold on to your hats because it gets even stranger. To help us grasp this concept, let's turn to a famous thought experiment proposed by physicist Erwin Schrödinger. Imagine a cat sealed inside a box with a radioactive atom. If the atom decays, it triggers a mechanism that releases a deadly poison, and the cat dies. If it doesn't decay, the cat lives. According to quantum mechanics, the atom is in a superposition of states, both decayed and not decayed. And because the cat's fate is tied to the atom, it too is in a superposition of states, both alive and dead. It's only when we open the box and observe the cat that it collapses into one state or another. It's a strange and counterintuitive idea, isn't it? But that's the beauty of quantum mechanics. It challenges our everyday experiences and forces us to look at the universe in a whole new light. So next time you can't decide between two things, just remember, a quantum particle wouldn't have to choose. What if I told you that two particles can be light years apart and yet behave as if they are right next to each other? This is no science fiction plot, but a real phenomenon in the world of quantum mechanics. Welcome to the intriguing concept of quantum entanglement. You see, quantum entanglement is like a dance, a beautifully choreographed performance where two particles, no matter how far apart, move in perfect sync. Picture two ballet dancers flawlessly executing their routine. They leap, spin, and pirouette in harmony. Now imagine these dancers miles apart, yet still perfectly synchronized, each movement mirrored by the other, instantaneously. This is the essence of quantum entanglement. In this cosmic ballet, particles become intrinsically linked, forming an invisible, unbreakable bond. The state of one particle instantly influences the state of the other, no matter how vast the void between them. Change the spin of one, and the other responds in kind. It's as if they are whispering secrets across the expanse of space and time, secrets that we are only just beginning to understand. This phenomenon defies our everyday understanding of the world. It's a concept so strange, so counter to our everyday experiences, that even the great Albert Einstein was taken aback. He famously dubbed it spooky action at a distance. So there you have it, quantum entanglement, another fascinating facet of the quantum world. As we've seen, the quantum world is bizarre and fascinating. It challenges our everyday understanding of the universe. We've delved into the uncertainty principle, where we learnt that we can't know both the speed and position of a particle at the same time. It's a bit like trying to catch a slippery fish with your bare hands. We also explored the concept of superposition, where a particle can be in multiple states at once until observed. Remember our friend Schrödinger's cat, who was both alive and dead at the same time? That's superposition for you. Lastly, we ventured into the realm of quantum entanglement, a spooky action at a distance. It's as if two particles, no matter how far apart, can instantly know what the other is doing. These quirky principles of quantum mechanics are not just theoretical curiosities. They are shaping our technological future, powering advancements in computing, communication, and more. And there you have it, a glimpse into the weird and wonderful world of quantum mechanics. Subscribe to our Universal Universe channel for daily cosmic adventures.